This is going to be a teardown video. This is a Bausch&Lomb Spectronic Mini 20. It's obviously a fairly old piece of equipment. It probably dates to the 70s. I spent all of $40 on it at eBay. However, I hope it's going to be a good example of finding some very precise components inside of it. I'm trying to build a better spectrometer, and this is listed as a water testing device for testing, I presume, for pollution and such. Not you put a vial into here, and you can then look at the absorption over various light frequencies, which essentially should be a spectrometer inside there, or a monochromator. It's got all the bits you might expect. It's got this little dial here that has a nanometer marking on it, and of course that's for light. I presume this is going to show the absorption. And on the back here, it's quite interesting. It actually has a little light bulb, and unlike a spectrometer where you're trying to shine light at it, this one actually comes with its own light source. And I presume this is going to be a fairly unusual bulb. I presume there's a lot of interesting things going on there. It probably has a very flat spectral response. Anyways, it was a battery-powered device. The battery, unfortunately, long gone, I guess. Built by a company which is also, I think, long gone. Bausch&Lomb had a huge facility in Rochester, New York. And it was one of the big employers there. It's a beautifully made case. It's some sort of die-cast metal, but I want to tear it apart and see what's inside there. I think I'll find some neat parts. Okay, just opened up the case, and indeed, I've been rewarded with I think, a really nice buy. I just moved this arm across. You can see inside there is a bit of mirror-like substance, and that is almost certainly a diffraction grating. Well, that's pretty awesome, actually, because it's going to be undoubtedly of very high quality, because I'm presuming this instrument actually was a fairly expensive bit of kit at the time. Obviously, this screw is attached to this dial here, and it dials the number of nanometers, and that would move this arm. I've just disconnected it so you can see the movement. Again, nice and precise. That's kind of interesting. And light source was here, and it looks like it shone down somehow on a path here, and then it must have shined on the sample. The sampling kit also looks like it has a some sort of electronics as well, so light came in, and then it produced an output, which I presume gets fed back into the meter somehow. So I think the sensing portion of it will be in this box here. This is mostly the light pattern. It was battery powered. They had a DC adapter that came in. I'm presuming that this is going to be a charge circuit of some sort. You can see it's definitely old school. It looks like the board was actually laid out by hand. So yeah, we're probably definitely talking 70s. I'll be able to read this semiconductor here once I get the board out, and I get a date off of it. That's obviously one of the easiest ways of dating some electronics. A very nice meter movement here. Looks like it was probably bespoke for the meter's design. Really lovely quality components, and that's the nice thing you can get when you buy some really obscure bit of kit. Inevitably, you get some nice stuff that would cost a small fortune if you try to buy something new. So let's take a look at this board here next. So the board's free now, and this is a 555 timer chip. Has a date of 1979, so indeed, this is a 1970s design board. This is a wet slug tantalum capacitor. These have a good habit of blowing up. I've managed to put a few into tiles of the roofs of companies I worked for, and you reverse voltage a wet slug tantalum. It is quite exciting and very obsolete. Polymer film tantalums are much more common now. Power input. This was a button for checking the battery, I recall, and you can see there's no silk screen on the board. It's and there's in fact there's no solder mask either. It's literally just a two-sided circuit board, almost something like you'd build at home these days. But back in '79, I guess, state of the art. All the traces you can see were laid out by hand. No CAD tool required. So single-sided assembly, and obviously very costly to assemble. The hand-made ribbon cable here, snaking off into the rest of the instrument. So. But that was fine, of course. This is a high-end piece of scientific equipment, so it didn't have to be super cheap to manufacture. This should be a fairly easy circuit to trace out to see what's going on, but before I do that, let's move on to the sampling kit here. I presume there has to be some sort of receiver of some sort in here. So let's see what this is made out of. Okay, just looking straight down on the instrument, the light bulb is over here, and just notice I also scored what is a mirror, but it's been silvered on the primary side. Unlike a mirror you'd use sort of in a house or like a bathroom or something, these mirrors are special, and the silvering is on the top, so there's no distortion passing through the glass. And if I use my flashlight here, I can see the beam path. It shines through here, bounces off the mirror, then bounces into the diffraction gradient, then it continues on to where the sampling head module sits, this little gadget here. So 2 scores now. I got myself a diffraction grating, and I've got a beautiful mirror. Both these actually would be worth more than the $40 I paid for the whole instrument, so a couple buys. Okay, so the little vial of water sat down in here, and I believe this is some sort of sensor, probably a photovoltaic cell of some sort, because if you shine the light down, you can sort of see there's an optical component to it. And 2 wires run off. Now, they run off to a circuit board here. Unfortunately, we run into our old friend potting compound. This almost certainly won't be a reworkable potting compound. It's probably very hard and brittle. So it's going to be very tricky to actually take this apart to see how this circuit works. Associated with it was some sort of attenuator, I think. I think this is TU is turbidity units. So this one looks a little easier to access. So let's take a look at this circuit board. So it's always fun to tear down really high-end equipment. There's not just one set screw, but there's actually 2 to ensure that the dial never actually ever moves out of place. So just the sort of things you see when you have money to spend on electronics. Such a refreshing change. I've been tearing down so many of those inexpensive light bulbs on my channel, and a whole different discipline of engineering. And this one is kind of in the polar opposite direction, where you have the economic freedom to build a high quality assembly. Well, it's still stuck on pretty good. Maybe the old screwdriver has to come out. Little persuasion. Okay, I just finally got the case off. This was the selector switch that was held on by those 2 grub screws. If you look closely, the whole assembly has been conformally coated. It's basically a clear coating on the circuit board, so any contamination, any water that got into the assembly wouldn't affect the electronics. It makes sense. This was a meter designed to measure water, so nice care taken there. Some multi-precision turn pots for each of the range settings. I presume you can trim it up. And then a small integrated circuit here and a couple of transistors. Unfortunately, cordwood construction where everything gets soldered together, so makes it a little more challenging to keep the reverse engineering going there. I'm not quite sure I want to take it apart fully yet, because I actually want to use this assembly in a spectrometer. So yeah. Okay, so impossible to read on this video, but when I zoom in with a magnifying glass, I can read the manufacturer code, National Semiconductor, which was at one time a very large company also. They're now owned by Texas Instruments. It's a M324, that's a quad op amp, so, and that all makes sense. I'm not quite sure whether or not the transistor was purposely thermally put close to the op amp, or that was just simply just a side effect of the assembly, but I do know they touch. So obviously an attenuator with op amp, so all makes sense. So just another view of this. I believe the light receiver with the 2 wires on it has a slotted screws. You wouldn't see that anymore. Not too manufacturing friendly. But there's 2 very thin wires coming out, and this enclosure is custom made, it looks like, and it's also held on by a set screw. And there's clearly a lens down here, so fairly tricky assembly, but I presume it's all been calibrated so it shines a precise amount of light onto that detector, and undoubtedly what this is an amplifier. Well, there you go. I think I got myself a bunch of parts, obviously, but the beginnings of a new spectrometer, I suspect. Just need to reverse engineer those circuits here, and that looks like it's going to be very easy because all those parts are well marked with clear indication of what they are. And the potting compound here might defeat me, I must admit, but You should be able to divine at least, there's only 4 outputs on the module, so it shouldn't be too hard. I presume 2 will be power and 2 will be the signal. So there, another project to put on my list.